What if the nose on your dog's face isn't actually its most powerful smelling tool? That sounds impossible, but here's the thing. Dogs carry a second, entirely separate smelling system hidden inside their mouths. It's called the Jacobson's organ, also known as the vomeronasal organ, and it has one purpose: detecting pheromones. These are chemical signals that animals produce to communicate, carrying information about identity, emotional state, even reproductive status. While your dog's main nose is busy cataloging the scent of whatever you made for dinner, this hidden organ is quietly reading a whole other layer of the world that you cannot perceive at all. You can actually find the entrance to it on the roof of your dog's mouth. Just behind the front teeth, there's a small bump called the incisive papilla. Right in the center is a tiny hole, a duct that leads directly to the Jacobson's organ. Dog owners who notice it for the first time often panic and rush to the vet, assuming something is wrong. Nothing is wrong. That bump is the doorway to a second sense. And that's before we even get to what the regular nose is doing. Dogs carry around 300 million olfactory receptors in their noses. Humans have about 6 million. The region of the brain dedicated to processing smell is roughly 40 times larger in dogs than in us, proportionally. To feel what that actually means, researcher Alexander Horowitz found that where a human can taste a teaspoon of sugar dissolved in a cup of coffee, a dog could detect that same teaspoon dissolved in 1 million gallons of water, enough to fill 2 Olympic swimming pools. But even that undersells it. A 2020 study from Sweden found that a dog's nose can detect something no one expected: heat. Thermal radiation. The researchers challenged dogs to choose between a warm object and a cool one from across a room, and the dogs could do it reliably. That makes dogs only the second mammal on the planet known to possess this ability. The first is a vampire bat. The wet surface of a dog's nose isn't just there to trap scent chemicals. It can feel the warmth radiating off a living body nearby. Even when it cannot see that when your dog freezes and stares into the dark, nose working quietly, it might not just be smelling something. It might be feeling it. You walk through the front door after the worst day of your life. You haven't said a word. You haven't cried. And yet, within seconds, your dog is pressed against your leg, quiet, still, watching your face. That's not a coincidence, and it's not just training. Scientists have confirmed that dogs are genuinely reading you, that a study published in the journal Biology Letters found that dogs can recognize human emotions by combining 2 separate senses at once: sight and hearing. They cross-reference the expression on your face with the tone in your voice, integrating both signals to form a complete emotional picture. And here's the part that raises eyebrows. They can do this across species. They don't just read other dogs this way. They read us. What makes this remarkable is that no one taught them to do it. It emerged from thousands of years of living alongside humans. Research into domestication shows that this fine-tuning is built into the dog brain in ways that even their closest wild relatives don't share. When scientists studied hand-raised wolves, animals raised around people from birth, those wolves did not respond to human eye contact the way dogs do. The domesticated dog evolved something the wolf never had: a hardwired system for locking onto human emotional signals. And the emotional response goes both ways. A 2019 study found that during stressful moments, some dog-human pairs showed synchronized heartbeats, their cardiac rhythms literally falling in a step with each other. Your dog isn't just observing your feelings, they're catching them. Then there's jealousy, which turns out to be very real. Research has shown that dogs become noticeably distressed when another dog receives a reward for the same behavior they just performed without one. That look your dog gives you when you're petting another dog, that tight and watchful expression, it's not theater. It's an actual emotional response, the same way a child reacts when a sibling gets a bigger piece of cake. There's also the crying experiment. Dogs were more likely to approach and comfort a person who was crying, even a complete stranger, than someone who was simply humming or speaking calmly. They weren't responding to familiarity. They were responding to distress, as, oh, the next time your dog fixes you, with that searching, steady gaze, they're not daydreaming. They're doing something no other animal on the planet does quite so well: reading a human being one emotional cue at a time. That dog sprawled on your couch, legs completely limp, eyes closed, totally unresponsive to the television, the traffic outside, even the sound of a bag of treats being opened. Looks like nothing is happening. But inside that skull, the brain is firing with activity every bit as complex as yours did this morning when you were fully awake. Studies measuring brain wave patterns in sleeping dogs have found they move through sleep stages that are remarkably similar to ours, including REM, rapid eye movement sleep, the phase where humans do nearly all of their dreaming. And when researchers studied animals during REM sleep, they found something that changed how scientists think about dreaming entirely. The brain does not simply idle during this stage. It replays the day. In rats, scientists, including researchers at MIT, found such rich, complex dream activity that the animals appear to be mentally rerunning the specific routes they had traveled while awake. The implication for dogs with their similarly structured sleep cycles is hard to ignore, because here's what we actually see when a dog enters REM. The paws start paddling, the nose twitches, the lips pull back, and sometimes a muffled bark escapes, all while the dog never fully wakes. Surveys of dog owners put leg twitching at close to 3 in 4 dogs. That paddling, that yipping, maps almost perfectly onto what you would expect from a dog mentally sprinting after the squirrel it spotted on the afternoon walk. Scientists believe dogs use sleep to process the events of the day. So the bundle of fur going still on your kitchen floor is not doing nothing. It is in all likelihood replaying the park, the greeting at the front door, the stick thrown in the yard. Not every dog dreams at the same pace. Puppies and senior dogs dream far more frequently than adult dogs in their prime. Smaller breeds also tend to cycle through dream episodes more often than larger ones. There's something quietly remarkable about that. The relationship you have with your dog does not simply switch off when sleep arrives. The evidence suggests their brain keeps turning over the day you shared, still processing you, still replaying the walk that ended hours ago, still finding it, apparently, worth dreaming about. Here is something the researchers almost never mention. During the years they spent testing Chaser's vocabulary, her human handlers had to write the name of every single object on a slip of paper and tape it to the toy, just to keep up with her. The dog remembered all 1,022. The people in the room needed cheat sheets. That one detail tells you everything about what kind of animal Chaser was. Most dogs land somewhere between 150 and 250 words, commands, names, a handful of nouns picked up from simply living alongside you. That already puts them roughly on par with a 2-year-old child, which is remarkable enough on its own. But Chaser didn't just approach that ceiling. She blew past it entirely. She was a Border Collie, born in 2004 in Spartanburg, South Carolina, and from the time she was 8 weeks old, a behavioral psychologist named John Pilley started working with her in a way nobody had ever tried before. Not tricks, not agility, pure vocabulary, up to 5 hours a day, 5 days a week for 9 years. He would hold up a toy, say its name, repeat it, let her fetch it, and then move on to the next one. The milestones kept coming. By 5 months, she knew 50 words. By 7.5 months, 200, already surpassing Rico, the Border Collie who held the previous record. By a year and a half, 700. By 3 years old, Chaser had crossed 1,000 named objects and showed no signs of stopping. But the number alone undersells what she could actually do. Chaser wasn't just matching sounds to objects by rote. She could sort them by category, grouping them by shape and by function, a form of abstract reasoning children typically don't develop until around age 3. She grasped the difference between nouns and verbs, and she could follow simple sentence structures. And her understanding wasn't confirmed once. It was validated through hundreds of separate fetch trials, each one designed to rule out coincidence and prove she genuinely knew what the words meant. Brian Hare, an evolutionary anthropologist at Duke University, called her the most important dog in the history of modern scientific research. Not most obedient, not best trained, most important, because what Chaser revealed about how a non-human mind can engage with language didn't just impress the scientific community. It changed the conversation about animal intelligence entirely. What if your dog has a body part you've never even noticed? One hiding in plain sight every single time you've looked into their eyes. Tucked into the inner corner of each eye is something called the nictitating membrane, a third eyelid. Humans lost this structure somewhere far back in our evolutionary history, but dogs kept it, and it does real work. It sweeps across the eye like a windshield wiper, clearing debris, spreading a protective layer of moisture, and actually producing about a third of the eye's total tear supply. Most of the time, you'll never see it. But if you ever spot a pale film creeping in from the corner of your dog's eye, that's it making itself known. And it usually means a vet visit is worth considering. That's not the only hidden surprise. Lean in close to your dog's nose, and you'll find a pattern of tiny ridges and bumps. Those are as unique to your individual dog as a fingerprint is to you. No two are ever identical. The Canadian Kennel Club figured this out as far back as 1938 and has been accepting nose prints as official identification ever since. Your dog is carrying a biological ID card on the very tip of their face. Then there are the ears. A human ear is essentially locked in place. A dog's is controlled by around 18 separate muscles. That's why your dog can swivel one ear toward a sound behind them while the other stays aimed forward. They aren't just passively listening. They're running a precision tracking system, able to locate the source of a sound faster than any human can, and picking up noises from roughly 4 times the distance we could ever manage. And here's one that hits differently on a hot summer day. You have sweat glands spread across your entire body. Your dog? Only on their paws. That's the whole list. Those small damp prints your dog leaves on the kitchen floor on a warm afternoon are not from water. That is actual sweat. For everything else, they depend entirely on panting to cool down, which is exactly why a hot car turns dangerous for a dog so much faster than it ever would for us. Same house, same couch, same afternoon nap, but an entirely different body underneath. Picture it. The starting gun fires. A cheetah explodes off the mark. A blur of spotted muscle that's already pulling ahead before the greyhound has fully found its stride. At speeds up to 70 miles per hour, the big cat looks completely untouchable. For a moment, it seems like no contest at all. For about 200 yards, it is, then something changes. The cheetah slows. Its sides heave. It stops. That's it. The world's most famous sprinter is spent after roughly 2 city blocks, physically unable to keep going. All that raw, blinding speed, and it simply runs out. The greyhound, meanwhile, is just warming up. This is what most people get completely backward about these two animals. A cheetah is a missile, devastating over a short distance, then finished. A greyhound is built for something else entirely, sustaining speed long after everything else has quit, but a greyhound can hold 35 miles per hour not for seconds, but for miles. Up to 7 miles, in fact. That is the length of more than 120 football fields, covered at highway speed, without slowing down. The cheetah flamed out before the first stoplight. The greyhound is barely past first gear. Run the math on any race longer than a quarter mile, and it isn't even close. The cheetah is standing in the dust, sides heaving, while the greyhound is still a dot on the horizon, perfectly composed. Part of what makes greyhounds so eerily efficient is how they actually move. At full speed, a greyhound spends up to 75% of its time completely airborne. It isn't so much running as continuously falling forward with extraordinary precision, mile after mile. There's something almost counterintuitive about this. The most celebrated fast animal on Earth loses to a dog in any race longer than a short sprint. Speed means nothing if you can't sustain it. The ability to keep going, to stay fast long after the competition has collapsed, is where the real champions live, and the greyhound isn't even the most formidable canine hunter on the planet. That title goes to the African hunting dog, which scientists call the most successful hunter in the world. Dogs didn't just become our best friends. In a few extraordinary cases, they became the most effective hunters this planet has ever seen. What if the most powerful cancer screening tool in the world has 4 legs and a wet nose? Most people assume that detecting cancer requires expensive scanners, blood panels, and hospital labs. But trained dogs have been doing something those machines still struggle with: identifying cancer simply by smelling a person's breath. Here is why that works. Cancer cells do not behave like healthy ones. As tumors grow, they release distinct metabolic waste products called volatile organic compounds that healthy tissue does not produce. Those compounds make their way into breath, urine, and sweat, creating a smell that, to a dog, is unmistakable. A dog's sense of smell is estimated to be between 10,000 and 100,000 times more sensitive than humans. To put that in perspective, researchers describe their detection threshold as roughly 1 part per trillion, the equivalent of 1 teaspoon of sugar dissolved into 2 Olympic-sized swimming pools. The first documented hint of this came in 1989 when a woman visited her doctor about a mole her dog would not stop sniffing and trying to bite. It turned out to be a malignant melanoma. Since then, the science has caught up. Studies have shown trained dogs can identify ovarian, lung, colorectal, and bladder cancers by smelling breath or urine samples. Dogs at the University of Pennsylvania correctly identified a specific canine cancer called hemangiosarcoma about 70% of the time, a rate consistent with other cancer detection studies. What makes this even more remarkable is the timing. Dogs can pick up the scent even before the cancer has spread from its original site, before any symptoms appear, before a scan would catch anything. At training programs like the In Situ Foundation, dogs spend up to 8 months learning the smell of cancer, working through more than 300 unique samples of breath, urine, and saliva. By the end, they can sort through 10 samples in just 30 seconds. And here is the detail that might genuinely stop you. A bloodhound sense of smell is considered so reliable that scent evidence from a bloodhound has been accepted in courts. The nose of a dog, in other words, is not just impressive, it is legally credible. The olfactory center of a dog's brain is roughly 40 times larger than the equivalent structure in a human brain. They are not simply smelling more than we do. They are living in a completely different sensory world, one where the earliest whisper of a disease we cannot yet see is already unmistakably loud. Here is a quiz most dog lovers fail. Name the 3 passengers who survived the Titanic's sinking, and name them by breed. Most people draw a blank. The answer is 2 Pomeranians and a Pekingese. 3 dogs made it off that ship alive that night in 1912. Every single one from first-class cabin, carried into the lifeboats as the vessel went under. It is one of those facts that sounds completely made up, like something someone slipped into a trivia book to see if anyone was paying attention. It is not made up. It is documented history. The Beatles' fact gets the same reaction. Most people assume that a day in a life ends with that enormous crashing piano chord. And that is it, song over. But embedded at the very end of the track is a high-pitched frequency, pitched so far above the range of human hearing that we cannot detect it at all. Dogs can't. Your dog may have perked up at the end of that song for years, and you had no idea. Then there is the Saluki, a breed most people would not recognize by name. Ask almost anyone to name the oldest dog breed on Earth, and they will guess something wolf-like. The correct answer is a lean, long-eared hunting dog from the ancient world. The Saluki was kept as a royal pet in ancient Egypt around 329 BC. But here is where the timeline becomes almost hard to process. Carvings discovered in southern Iraq depict a dog that looks unmistakably like a Saluki, and those carvings date back to 700 BC. 9,000 years ago, Before the wheel, before written language, before almost everything we associate with civilization. This breed has been a loyal companion through the entire recorded arc of human history. And then there is Bluey, an Australian cattle dog born in 1910. Bluey lived for 29 years and 5 months. To put that in perspective, most dogs live somewhere between 10 and 13 years. Bluey nearly tripled that upper end and kept going, all the way to 1939. He holds the Guinness World Record for the oldest dog ever documented. No dog has come anywhere close since Point 4 Facts. All of them verified, all on the record. If any one of them caught you off guard, subscribe. This series has a lot more where that came from, and none of it is made up.